If it's a minus, it's a minus here, right? So sine keeps the sign. It's a homonym, sine and sine. Now I'm signed about the homonym. So that's cosine alpha plus or minus beta is cosine alpha cosine beta. So you see there's this curious sort of thing where they're the same, but the signs are different. So if this is a plus, then this is a minus. If that's a minus, then this is a plus. Right? And then these are both sine alpha, sine beta. And
So you,
tangent?
you swap the signs is basically what you're saying
Yeah.
for that notation.
SIGN signs, yeah. Tan also has an addition identity. What's that one? Well, you keep the sign on the top. So if it's plus here, then it's plus here. If it's minus here, then it's minus here. And on the bottom, you reverse it. So if it's plus here, it's minus here. If it's minus here, then it's plus here. And this is the product. Okay. So those are worth memorizing, because they're hard to derive, right? We have a way of deriving these things using the distance formula. There's another way using area. Should we do that?
Distance formula is what I remember. It'd be nice to have a refresher.
Oh, yeah, so we could refresh that. Say that the distance formula is, if you've got two angles here, alpha and beta, then this is going to be cosine alpha, sine alpha, right? By definition, this is the unit circle. So the terminal point traveling at distance alpha around the perimeter will take you to that terminal point, and then up here we'll have cosine alpha plus beta, right? Because we got the two angles together, right? They added up here. And sine alpha plus beta is the terminal point up there. And then yeah. So I guess that's not the way. Yeah, I guess that's one way of doing this, right? So if I then, okay, so if I have this point, which is P naught is 1, 0, right? That's the starting point for your dialing up your angle, and we dial up counterclockwise. And so if this is P1, well, let's label it up here, P1. Then this chord is a certain distance, P naught, P1, and the square of that distance by the Pythagoras' theorem. If I drop a perpendicular here, the difference in the x-coordinates, so I'm going to write P naught, P1 squared is the sum of the squares of the difference in the x-coordinates, which I'm going to write 1 minus cosine alpha plus beta. Squared, right, that's this distance here. And this vertical distance is going to be the difference in the y-coordinates. Well, it's going to be sine alpha plus beta minus 0 squared. And so now if I rotate this whole thing, I'm going to get the same chord. The chord is invariant, right? It depends only on the central angle. So if I rotate this like so, so that this is angle alpha and this is angle beta, then the interior angle is still salud. that's a little messy, isn't it? Maybe if I erase this perpendicular coming down here. Yeah, and this as well. Kind of cluttering things up, right? So then I've got Q naught, P naught rotated down to Q naught. I rotated it counterclockwise. Sorry, I rotated clockwise, didn't I? The whole thing by an angle of alpha, so that this point here is the opposite of this point up here, right? So this is going to have coordinates, the x coordinate is the same, and the y coordinate is going to be opposite. Right, so that's the reflection of this point across the x-axis. Yeah. See if I can connect these more readily like so. All right. And then Q1 here is going to be cosine beta, right? This angle here is beta, sine beta. And so Q naught Q1 squared is going to be the difference in x coordinates between here and there. All right, so this one has an x coordinate of cosine alpha, this one has an x coordinate of cosine beta. You can say cosine alpha minus cosine beta is that difference. And to square the difference will give me the horizontal leg of the right triangle. And the vertical leg, what right triangle? Well, this is the hypotenuse of a right triangle. It looks like this. That's a right angle. So this distance here is that cosine alpha minus cosine beta, right? And this vertical distance is going to be sine beta minus negative sine alpha. And those have got to be equal, right? Because they're chords that subtend the same central angle, alpha plus beta. So we expand all that out and use the Pythagorean identity a couple of times, right? I suppose we should do it, huh? We did it before. It bears repeating, I guess. All right, so it's in your notes probably somewhere, right? It's in the book. We have that Q naught Q1 squared equals P naught P1 squared. They both subtend central angle alpha plus beta in the unit circle, right? So I'm going to expand this and get cosine squared alpha plus minus, right? 2 cosine alpha cosine beta, oh, there's that product. And then plus cosine squared beta. All right, that's the expansion of that. Here's the expansion of this. Sine squared beta. Now these cancel out, right? So it's going to be a sum. And so that's going to be plus 2 sine alpha sine beta. Oh, there's that product. And then plus sine squared beta alpha. Beta. And that's all equal to this squared, which is going to be 1 minus twice cosine alpha plus beta. Well, there's the cosine of the sum. Plus the square of the cosine alpha plus beta. And we're going to get the square of the sine from the second square, right? So these add up to 1 because Pythagoras. And these add up to 1 because Pythagoras. What these? And then these add up to 1 because of Pythagoras. So we got a bunch of 1s, right? That's going to make this a lot simpler. So you got 1 plus 1 is 2 minus 2 cosine alpha cosine beta. It's just, busy work here. It works out. We've done it before. And this is going to be equals, right? This equals 1 plus 1 is 2 again, minus 2 cosine alpha plus beta. And you see that's going to mean these 2's cancel out. You can subtract 2 from both sides if you like. And multiply both sides by -1/2. And you get your cosine identity. This one with a plus sign, right? Cosine alpha plus beta is cosine alpha cosine beta minus, right? Because we're going to be multiplying by -1/2. Yeah. So here's the other proof. I have to remember how it goes. So if I got a triangle like this, which is obtained from a right triangle, with angles blah, 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 blah. And something's equal to 1. Maybe I shouldn't try this without having remembered it first. Well, we'll try it. Okay, so I'm going to say this is triangle.